Hello my dear students, today we are going to discuss with the interior of the skull base, that too with the middle cranial fossa. In the last lecture we have discussed about the anterior cranial fossa. Introduction. So as will complete the interior of the base of the skull, it is a calvaria minus skull cap which is observed from inside, that is a cranial cavity or that which lodges to the brain parties. Now subdivisions of the uh, interior of the skull, that is internal surface of the base of the skull is naturally demarcated into three fossae, that is the anterior cranial fossa, middle cranial fossa and posterior cranial fossa. So these are the two demarcated lines are present. This is one is the anterior demarcated line and the second one is the posterior demarcated line is there. So area present anterior to that of an anterior demarcated line, that used to call as an anterior cranial fossa. A part present posterior to that of an anterior demarcated line and anterior to that of a posterior demarcated line, that used to call as the middle cranial fossa. So today we are concerned with the study of a middle cranial fossa, what the structures are present, what structures are used to form the middle cranial fossa, what are the foramina are present and what their contents are there. So let us start. Boundaries. First we will discuss about the boundaries, that is anteriorly or the anterior boundary. It is formed by posterior border of lesser wing of sphenoid bone, that just the blinking line you are seeing that. Then there is an anterior clinoid processes. These are the anterior clinoid processes and anterior border of sulcus chiasmatis. So this is the anterior border of sulcus chiasmatis. This is the clinoid processes and this one is the posterior border of a lesser wing of sphenoid bone. This all three structures combines to form the anterior boundary of middle cranial. Now posterior boundary of middle cranial fossa, that superior border of petrous part of the temporal bone, superior border of a petrous part of the temporal bone. This is the superior border of a petrous part of the temporal bone. Posterior clinoid processes. This is the posterior clinoid process and dorsum sellae. These three structures combines to form the posterior border of middle cranial fossa. Next is a lateral boundary on each side. It is formed by greater wing of the sphenoid bone, squamous part of a temporal bone and anterior inferior angle of the parietal bone. So this is the anterior inferior angle of the parietal bone. This is the squamous part of the temporal bone and this is the greater wing of sphenoid bone. So all these three structures used to be forms the lateral boundary of the middle cranial fossa. Next is the floor of the middle cranial fossa. So floor of a middle cranial fossa, in a central portion it is formed by body of the sphenoid bone. On a lateral portion, that is formed by greater wing of sphenoid bone, anterior surface of a petrous part of a temporal bone and squamous part of temporal bone. Now comes to the contents. What the structures forms the middle cranial fossa and what the foramina are present, that we are going to discuss. So first structure is the sulcus chiasmatis. Sulcus chiasmatis, it is a transversely running groove just behind the jugum sphenoidale. So just you see in a bony part, this is the jugum sphenoidale. Just posterior to that, the blinking structure that you are seeing, that is called sulcus chiasmatis. Sulcus chiasmatis leads laterally into the optic canal. So you are seeing that here is the optic canal is being seen. This is the part of the optic canal that is present and it is laterally, it leads into the optic canal. Optic canal, it connects the middle cranial fossa with the orbit. It transmits optic nerve, ophthalmic artery and meninges, that is leading from the through the optic canal to the orbit. Next structure is tuberculum sellae. Tuberculum sellae. It forms an elevation just behind the sulcus chiasmatis. Middle clinoid processes are the lateral prominent ends of the tuberculum sellae. It receives attachment of anterior margin of diaphragmatic sellae. This is a structure that used to see. This part is called the tuberculum sellae. Just as it is present posterior to that of sulcus chiasmaticus. This is the sulcus chiasmaticus and this is the optic canal. Next structure is a SELLA TURCICA of the sphenoid bone. Specifically, it is a very important structure. It is a hollow behind the tuberculum sellae. It is a hollow structure present just posterior to that of tuberculum sellae. It is shaped like a Turkish saddle. It is a shape like a Turkish saddle and therefore named as a SELLA TURCICA. Hypophyseal fossa is the deepest part in it. It lodges the pituitary gland. Actually, pituitary gland is situated in this structure that used to call as the SELLA TURCICA of the sphenoid bone. This is the position of the pituitary gland. Sphenoidal air sinuses is present below the floor of the hypophyseal fossa. So this is the SELLA TURCICA of the sphenoid bone that you are seeing, and this is the hypophyseal fossa is present in which the pituitary gland is found to be situated. Just beneath to that or the inferior to that structure is the sphenoidal air sinuses are present, which are present in the body of sphenoid bone. Next is the dorsum sellae. Dorsum sellae, it is the back of the Turkish saddle structure. It is a square plate of bone that is situated behind the SELLA TURCICA of the sphenoid bone. Superior angle of a dorsum sellae projects laterally and they forms the posterior clinoid processes. So this is the dorsum sellae and that is the projections are present. These projections used to be forms the posterior clinoid processes. This is the part of the dorsum sellae that used to see in the closer view, and from here there are the processes are present. These processes are called posterior clinoid plates. These are the anterior clinoid processes. These are the anterior clinoid processes, and this is the posterior. In this bony structure, these posterior clinoid processes are broken. Now comes to the superior orbital fissure. It is one of the important structure present in the middle cranial fossa. So it is a triangular fissure which connects the middle cranial fossa with the orbital cavity. It is bounded above by lesser wing of sphenoid bone, whereas below by the greater wing of sphenoid bone and medially by body of sphenoid bone. So it is completely situated in the sphenoid bone parties. So superiorly it is bounded by lesser wing and then by below by the greater wing and medially by the body parties. The common annular tendinous ring or the ring of Zinn divides the fissure into lateral, middle and medial parts through which the structures passes from middle cranial fossa to the orbit. Specifically, there are the structures, very important structures. Specifically, there are the nerves, that is the third, fourth, fifth, and sixth cranial nerve. There's a third cranial nerve is oculomotor, fourth is trochlear nerve, whereas the ophthalmic division of a trigeminal nerve, and sixth one is the abducent nerve. These three bones, and that is one of the division of a fifth cranial nerve that used to be passes through the superior orbital fissure. Right orbit, anterior view of the superior orbital fissure. Right orbit, anterior view of superior orbital fissure. What the structures passes to the lateral party. So this is the lateral part. This is middle. This is the lateral part that your blinking area is being seen. Middle part, medial part, and this green colored structure that you are seeing. This is called ring of Zinn. That ring of Zinn has divided the superior orbital fissure into the three parts. That is the medial, middle, and the lateral party. So in this slide we are concerned with the lateral part. So structures passes through the lateral parties. First is a lacrimal nerve, frontal nerve, trochlear nerve. Trochlear is a third cranial nerve. Then superior ophthalmic vein, meningeal branch of a lacrimal artery, orbital branch of middle meningeal artery. These structures used to be passes from the lateral part of a superior orbital fissure. Next is the superior orbital fissure, that is a middle part or through the common annular tendon structure. So this is the middle part, that is a blinking area that you are seeing. So the upper and lower divisions of the oculomotor nerve, that is a third cranial nerve that used to be passes through the middle area, is nasociliary nerve and abducent nerve. Sixth cranial nerve also used to be passes through the middle parties. Next we are saying with the medial part, that is a medial part of a superior orbital fissure, that is blinking area that you are seeing. Inferior ophthalmic vein, whereas sympathetic twigs forms internal carotid sympathetic plexus. This is the mnemonic for the structures which passes through the superior orbital fissure, that is I slept one night and left for Tokyo, in which I stands for inferior ophthalmic vein, S stands for sympathetic twigs, O stands for oculomotor nerve, N stands for nasociliary nerve, A stands for abducens nerve, L stands for lacrimal nerve, F stands for frontal nerve, T stands for trochlear nerve. So these structures ultimately used to be passes from the superior orbital fissure. By this mnemonic, you can remember the structures passes through it is. Now comes to the next foramen, next contents of the middle cranial fossa, that is foramen rotundum. It is important one is, it is present in a greater wing of the sphenoid bone first. Next, it is located just below and behind the medial end of a superior orbital fissure. It leads forwards into pterygopalatine fossa. So it is anteriorly, it is a connection of middle cranial fossa with the pterygopalatine fossa. This is one of the important points. Then it transmits the maxillary nerve. This is a very important part in this of the fossas present is it transmits the maxillary nerve. This is generally being asked because this is the only fossa which is not visible in the norma basilis view, and it used to be connects the middle cranial fossa with the pterygopalatine fossa. So this is your foramen rotundum being seen present is. This is the foramen rotundum. That foramen rotundum used to be passes the maxillary nerve. Actually, that maxillary nerve is 5B branches. 5B means it is the second branch of the or second division of the trigeminal nerve. Fifth B nerve is passed. Next is foramen ovale. Again, it is one of the important foramina of a middle cranial fossa. It is a oval in shape, so that it is called ovale. It transmits the mandibular nerve, accessory meningeal artery, lesser petrosal nerve, and imagery vein. These structures used to be passes from the foramen ovale. So this is the foramen ovale present. So this is your optic canal. This is superior orbital fissure. This is foramen rotundum. This is foramen ovale. So actually here is at up to it approximately at this level there is the trigeminal ganglion is present. That trigeminal ganglion used to be gives the three divisions. That is, one is the ophthalmic division, one is the maxillary division, and another one is the mandibular division. So ophthalmic, maxillary, and mandibular division. In this way, these all three divisions, that is a 5A, 5B, and 5C is there. That used to be passes from the middle cranial fossas to the different respective aspects. Now comes to the next foramina, that is foramen spinosum. That it is present near the spine of the sphenoid bone and posterior lateral to the foramen ovale. It transmits the middle meningeal artery, nervus spinosus, which is a meningeal branch of mandibular nerve, then parietal trunk of middle meningeal artery. So it is also remembered by 3 M's. All M's are there in. This is the foramen spinosum present. So this is foramen rotundum, ovale, and spinosum. Okay. So imagery foramen, that is the imagery sphenoidal foramen or foramen of Vesalius. It is inconstant foramen which is present posterior lateral to the foramen ovale. It transmits an imagery vein connecting the cavernous sinus with the pterygoid venous plexus. Now comes to the next foramina, that is a foramen lacerum. As the lacerated margins of the foramina is present, so that it is called foramen lacerum. It is situated between the sphenoid and apex of the petrous part of the temporal bone. It is named so because of its irregular margins that we have already discussed. Carotid canal and pterygoid canals opens into it. Foramen lacerum, next part is only two structures passes through it, that is a meningeal branch of ascending pharyngeal artery and imagery veins. Internal carotid artery transverses its upper part with its sympathetic and venous plexuses. This is the foramen lacerum. As used to see, there are the lacerated margins are being seen in the foramina. You see here the left side there is a lacerated margins are present. So this is the foramen lacerum is there. So again, if you to see once a revision of the all the structure that we have seen, that is this is the optic canal. This is the superior orbital fissure. This is foramen rotundum. This is foramen ovale. This is foramen spinosum. This is imagery foramen. Actually, this lower structure that can be remembered by, this is foramen rotundum. This is foramen ovale. This is foramen spinosum, and this is imaginary foramen. This is inconstant foramen. So these all these are present posterior lateral to this, posterior lateral to this, posterior lateral. Means foramen ovale is situated posterior lateral to the foramen rotundum. Foramen spinosum is situated posterior lateral to the foramen ovale, and imaginary foramen is situated posterior lateral to the foramen spinosum. So that can be remembered by the mnemonic that is called ROSE, R-O-S-E, ROSE. These are this ROSE is present actually in the greater wing of the sphenoid bone, and this your optic canal that used to be passes your optic nerve, that's superior orbital fissure, that used to be passes your third, fourth, fifth and sixth nerve. Then rotundum used to be passes to 5B, whereas ovale used to be passes to 5C. Thank you very much. Thank you.